All right, round 2. Let's hope the microphone is on this time. I have no idea. I will be really angry if it's not. So, let's try to get through these notes. First off, we have done the derivatives of arcsine, arctan, arcsecant, etc. Now we are going to do the antiderivatives. Now we have done the last one here, this. We have done this antiderivative. The one that we like the look of better of this is the antiderivative of 1 over u du. That equals our ln, absolute value of u plus c. That's the way we like to see it. Now, usually we would have to memorize it, but welcome to our future, and it is all open note all the time. So, Merry Christmas to all of you. All right, so we're going to take these. Now, notice, how do we kind of tell the difference? So, if we look at these, look at arcsine. It is the antiderivative of, really, a lot of times we like to write this as the antiderivative of 1 over the square root of 1 minus u squared du. This one here is going to be for tangent 1 over 1 plus u squared du. Notice tangent has no square root. Notice with arcsecant, arcsecant has the absolute value. So if you see that, you know that it's going to be arcsecant. So we've got 1 over the square root of u times the absolute value of u squared minus 1 du. All right, so let's get the party started. The first one, notice for all those arcsine, arctan, arcsecant, you've got a u squared, some term squared, along with a 1. If I look at this first one, looking at this, look at that 25x, 25x. 25x. It is not 25x squared. That term, if I took the square root of it, it would be 5 square root of x. You cannot, that x is not a perfect square. So this is actually our old stuff. How do I know? Because this term is not a perfect square. So what do we have here? We have our last one. So our first step is we're going to set that whole denominator equal to u. So I'm going to do u equals 1 plus 25x. Again, this is our old stuff. So we should have no trouble doing this one. 1 over u dx. Problem, we've got the dx, so we've got to get rid of that. Du equals 25 dx. Divide by the 25, divide by the 25, 1 over 25 du equals dx. Let's sub that back in. You should be golden on these. 1 over 25 times 1 over u du. Let's take that antiderivative then. And we are at 1 over 25 ln absolute value of u, which is 1 plus 25x plus c. There you go. Done. Now, number 2 looks very similar. However, this time it is 25x squared. So this is when it changes. So we're going to write out our steps. Step 1. Okay, we need to set something equal to u squared. All right, so I'm going to set 25x squared equal to u squared. There we go. Now I've got the antiderivative of 1 over 1 plus 25x squared dx. Now, step 2, we're going to solve for u. So I need to take the square root of both sides. So square root both sides. All right, so now I've got u equals 5x. What did I do here? I wanted to plug in 1 over u squared. All right, now I still have a problem here. I need to get rid of that dx. So I have to take now step 3 like we've been doing. Take the derivative. Take derivative of both sides and solve for dx. So du equals 5 dx, divide by 5, divide by 5. 1/5 du equals dx. Now let's sub in for my dx. So now I've got the antiderivative. I'm going to put that 1/5 in front of 1 over 1 plus u squared du. Perfect. Now we can look at this and we can say, okay, well, the 1/5 stays 1/5. Now look above. 1 over 1 plus u squared du, well, that is this one right here. That is our arctan with no square roots. That becomes arctan of u plus c. Now sub back in that u value. This will be so important. Star it, mark it, recognize wherever you put your u. 1/5 arctan of our u then is 5x plus c. There we go, we're done. All right, next problem. There we go. Let's look at it. Let's actually take all of what we have up here, copy. Hopefully I got it all. Copy. Let's then paste image. Yikes, I cut a little bit out, but that's okay. We know what they are. Okay, so now looking at it, do we have a u squared? I do. Do I have a 1 up top? I do. Fantastic. So now I'm looking at it. I'm going to step 1, figure out what is my u squared. U squared equals 289x squared. So now I've got the antiderivative of 1 over, this one has a square root. 1 minus, that's my u squared problem. I've got a dx. I need to get rid of my dx, so I need to go back to this and take the square root of both sides. U equals the square root of 289, 17x. This will be important. Now, take the derivative. Du equals 17 dx. Divide by 17, divide by 17. 1 over 17 du equals dx. Let's sub this back on in. All right, now I've got the antiderivative. I'm going to put that 1 over 17 in front times 1 over the square root 1 minus u squared du. Now we're ready to go. If you look below, we've got 1 over 17 stays. 1 over 17, the one with the square root and no absolute value becomes arc sine here. So that becomes arc sine of u plus c. Now let's sub back in our u. Arc sine, our u value is 17x plus c, and you are done. All right, let's look at the next one. Okay, I see what my u squared could be. Do I have a 1? Ooh, I do not have a 1 up top. Nor do I have a number up top. That is a huge indicator. This is old stuff. Wherever your higher power is, my higher power is in the denominator. Set wherever your higher power is equal to u. Set where higher power is equal to u. Okay, so now I've got x times 1 over u dx. So u equals 1 plus 4x squared. Du, so we've got this problem of dx and x. Du equals 8x dx. Divide by 8x, divide by 8x. 1 over 8x du equals dx. Let's sub this in for dx and only dx. So now I'm integrating x times 1 over u times 1 over 8x du. Notice what I can cancel. I can cancel just my x's and only my x's. I still have left this 1/8. I'm going to kick that to the front. So I have 1/8 times 1 over u du. I can now take that antiderivative. I get 1/8. The antiderivative of 1 over u becomes ln absolute value of u plus c. Now let's sub in our u value. ln absolute value, my u was 1 plus 4x squared plus c, and you are done. All right, looking at the next one. Oh boy. Looking at it, 1 is not up top. You can make that happen. You can just move the 2 out in front, and now you've got 1 over, oh weird, those absolute value signs. That's okay. Now we've got 9x squared minus 1 dx. Notice which one has our absolute value signs. That is right here. It says in the absolute value signs, which is 3x, that apparently is equal to our u. Okay, here, whoops, that's supposed to be a highlighter. Here, which is our 9x squared, is apparently equal to our u squared. 9x squared, let's see if that makes sense. If I took the square root of u squared, took the square root of that, oh, I do, by golly, Miss Molly, do get u. That makes absolute sense. So now we are integrating 2 times 1 over absolute value of u, square root of u squared minus 1, but I still, shucks, have dx. So I still need to take the derivative of u equals 3 dx, divide by 3, 1/3 du equals dx. I still need to sub on in. Sub that in. I am going to kick that 1/3 to in front times 2. Times still 1 over absolute value of u, square root of u squared minus 1 du. Now I am ready to take that antiderivative. 1/3 times 2, I've got a 2/3 in front. This whole ugly thing with that absolute value and that square root becomes that arcsecant. Arcsecant of u plus c. Now let's sub back in our u values. Arcsecant of u, which our u was just 3x plus c. And you are done. Looks good. Number 6. Very similar. We now have a number up top. Kick that number in front. So we've got 4 times 1 over. Looking in here, I'm going to make that my u squared. U squared equals 256 x squared. So the square root of 1 minus u squared dx. All right, we got to get rid of this dx. Square root both sides, u equals 16x du equals 16 dx. Divide by 16. Divide by 16, 1 over 16 du equals dx. Let's sub this in for this. Now I've got that 1 over 16 I'm going to put in front times 4 times 1 over 1 minus the square root of 1 minus u squared du. Now I can take that antiderivative. I've got 4 over 16. That reduces to 1/4. Now looking at this, there's a square root, no absolute values. That's just your arc sine. Arc sine of u plus c. All right, now let's plug it back in your u. 1/4 arc sine, our u value that we had here is 16x plus c. Now, looking at this, I've got a 225x squared, but a 25x. This one would be old info, old stuff, old stuff, old stuff, because it is 1 degree different. Old stuff. So you would have to make your u your denominator of 1 plus 225x squared. 8, just flip those around and it should work. And it would end up being your arcsecant. We will end there, and hopefully this time it recorded my voice. Let's see if I have to go for a take 3. Have a wonderful day. Enjoy.